We're on page 159 of your student journal. Just going deeper into number 3 in this video. So we have two tiles with numbers between 1 and 10 are chosen from two different bags. So we have tile 1 and we have tile 2. Or sorry, bag 1, I guess. Bag 1 and bag 2 where you're picking one of the tiles. It doesn't really matter. Bag 1, bag 2. And so the tiles could be, anywhere between 1 and 10. Then we have to find the probability, there are 100 possible outcomes. Okay, so when you frame a probability, the way it is framed is the total, the number of desired outcomes, or the things you want, over the number of possibilities, or the number of total outcomes. So in this case, we have two different problems here. The probability that the sum of the two numbers is not 10. This is important, is not 10. So we want to, sum, tells us to add, and we want to find the number of sums that are not 10. And so by starting off, we know the total number is 100 possibilities or possible outcomes. And the way we get that is there are 10 possibilities here, and there are another 10 possibilities here. So 10 times 10 is 100. Next, this is honestly just an issue of counting. So that's, what do I mean? Find the probability that the sum of the two numbers is not 10. So let's start off, 1 and 1. Does that add up to 10? If I add them together, no. 2 is not 10. So if it's not 10, we want to count it. So that's one way to make a number that is not 10, 1 plus 1. Then we have 1 plus 2, which is 3, which is not 10. Then we have 1 plus 3. Then we have 1 plus 4. Then we have 1 plus 5. Then we have 1 plus 6. Then we have 1 plus 7. Again, the reason I'm counting all these is that we want a sum that is not 10. So we have 1, 2, 3, 4, 5, 6, 7 numbers so far. 8 numbers, and 9. I do not count 1 and 9 because 1 plus 9, so in fact I'll do it in red, 1 plus 9 is 10, so we do not count that, but we count everything else. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9 numbers or 9 possible outcomes. And let's actually go back into this in blue. We have 9 possible outcomes. So in fact, what I will do to make this simpler is I will actually just count the ones that do not work out of the 100. So this one does not work. And we only have 100 outcomes, right? So 2 and 1 work, 2 plus 1, 2 plus 2, 2 plus 3, 2 plus 4, and so on and so forth. That all works. 2 plus 8 does not. 2 plus 9 works, 2 plus 10 works because none of those add up to 10. 3 and 1 work, 3 and 2 work, 3 plus 3 works, 3 plus 4 works. And the only one that does not work is 3 plus 7. So right now we have three possibilities that we are not counting because they do add up to 7. Or sorry, they do add up to 10. Then we have 4 and 6. Then we have 5 and 5. Then we have 6 and 4. Then we have 7 and 3. Then we have 8 and 2. Then we have 9 and 1. 10 adding any of these adds up to a number that is not 10. So, we really don't, there's nothing to count. They all work, so we don't have to count those. So now counting the red lines, the ones that are adding up to 10, we see that there are 1, 2, 3, 4, 5, 6, 7, 8, 9 possibilities that add up to 10. But we are looking for the ones that do not add up to 10. So if I have 100 total possibilities and 9 of them add up to 10, how many of them do not? And the answer is 91. So you could have done this one of two ways. You could say, okay, well, I want to make sure that it does not add up to 10. So I'm going to go ahead and count the ones that do add up to 10 and subtract it from the total. So 100 minus 9 is 91. And that's my work in the red lines. If you do not want to do that, then you could go ahead and say, okay, well, let's count all the ones that do add up to, let's count up the ones that do not add up to 10. So we have 9 here, then we have 9 here, then we have 9 here, and so on and so forth. And then for 10, we have to count all 10 of them because 10 plus any number besides 0 is not going to be 10. So that's it for number 3. I will tell you the answer for number 3, but you have to show your work. It's literally just counting, and you want to work it out so that the product of the numbers is greater than 10. So, yeah, the answer is 73% for part B, but if you don't show any work, then it counts for nothing. So there it is. Going down to number 6, the sections of a spinner are numbered 1 through 12. So I'm going to make a crappy looking spinner, try and make it as even as possible. So we got to make 12 even spots. So I've made 6. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7. Or 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, pretend it says each section of the spinner has the same area, so pretend I did it more evenly. The table shows the results for which number is the experimental probability of stopping on the number the same as the theoretical probability. So the idea is that, we're spinning something 180 times across 12, areas of the spinner, and if it has the same area, which my drawing does not, but this one does, then we expect it to land on each number the same amount of times, right? So all these numbers should be, in theory, the same. And what number is that? Well, you say, if we expect to be across all these evenly, if we are going to split them or divide them evenly, then you would take 180 spins and you would divide it evenly across 12 numbers. And you would get some type of number. And that is the theoretical probability, whatever you get. For which number is the experimental probability? So this, they spun it 180 times, and this is what actually happened. So which one of these results lines up with what we expect? You got to answer that. You got to figure out 1 through 12, which one has a result that lines up with what we expect. Next, use the spinner in exercise 6 to find the given odds in favor of stopping on a number greater than 8. So how many numbers do we have that are greater than 8? We have 4. It says in favor of. That means those are the ones I want. And then how many numbers do we have that are not greater than 8? Which are the rest of them? 8. So you go ahead and would reduce that to 1, 2, 2. And lastly, we have this against stopping on a number that is a multiple of 3. So multiples of 3 are 3, 6, 9, and 12. But it says against that, so I want the things that are not a multiple of 3, which is 1, 2, 4, 5, 7, 8, 10, and 11. There are 8 of those. And then how many of them are a multiple of 3? 1, 2, 3, 4. Or in simplified or reduced form, 2, 2, 1. So one thing I will press about probabilities and odds is that, like, when you, or the way I think about it is that when you have a probability you have the total number of outcomes here. Total. So like if we were thinking about any of these probabilities, then you would say, okay, well there's 180 total spins, right? So then you would split something by 180. But here, there is no total. Like there's a total of 12 numbers, right? But you don't see 12 anywhere in the actual thing. Or like earlier we had the tiles in number 3 or whatever it was, so the total outcomes over there was 100, right? But here the total outcomes are 12. You could hit 1 through 12, but you don't see that anywhere unless you add up the odds. But that's it for differentiating between odds and probabilities. If you have any questions, make sure you let me know.